Hello, friends. It's another beautiful week in Los Angeles. It's so sunny outside. I'm actually back in my own apartment in Los Angeles. I was in Irvine for a little bit, and I'm just back in my own apartment. I still don't have my kitties here, my cats, but they're with one of my roommates from before. So maybe in the next few videos, I'll get to show you guys my cats, which I'd be really excited to do. This is going to be our math video for today. It's something that we've done in the past a lot. So it's probably going to feel more of like a review or a refresher for a lot of you. And if it feels new or if it feels a little difficult, that's okay too. That's why we're here, to learn and to continue the learning. So I'm going to start by sharing our slides and our learning intention. So 1 second as I do that. All right, friends, so our learning intentions for today. Today we are going to focus on comparing fractions. Our success criteria: I can compare fractions with the same numerator and different denominators. I will utilize, for language intention, I will utilize vocabulary from our anchor chart. And our social intention, I do the work even when no one is looking. As we've always said in these last few weeks, that's our social intention. As always, we're going to go over the juicy vocabulary that mathematicians utilize in the classroom. So say it with me. Try to do the gesture with me. Remember, it's okay to say these words out loud in your apartment. It's so that you practice saying them and you know how to pronounce them. So the first one, numerator, denominator, benchmark fraction, 1/2, part, and then the whole, partition, right, when you partition, equal parts, equivalent, greater than, less than, equal to, a bar model, a pi model, a number line, unit fraction, and fractions greater than a whole. And some of the models and strategies that we've utilized are pi model, which is an awesome model. It is something that as third graders, we really want to make sure though that we have those equal parts, because that's when we can make mistakes. If we don't partition our pi model equally, it can mislead us, right? It can give us the wrong answer if we're not partitioning equally or correctly. Bar model, right? So that's one that we've definitely been utilizing a lot. And then the number line is also a great strategy, a great model to use. And then we have our fraction claims. And today we're really going to just focus, we're going to go back to one of our fraction claims and just really zero in on that fraction claim. And here we are. Actually, before we go into our claim, on Friday, I posted a video for Number Corner, and it was all about plotting fractions. So I actually want you to start off with the do now, which should review what I asked you guys to do last week. So make sure you get your math notebooks out and you're excited and you're ready to go. I want you to write all of this down in your math notebook. Label each of the marks on this number line. Make sure that you have the correct numbers right at the beginning of your number line, at the end, and look at how many tick marks you have in between. So I'm going to ask you to pause right now so that you can go do that. Okay? Pause, and then you're going to come back. All right, friends, you should have already solved, and you're ready to explore this answer with me, explore this question and see if you were able to answer correctly. So first of all, it says label each of the marks on the number line. So they're referring to these tick marks over here, which means, label, well, how am I gonna label it? Well, if I look at the number line, I see that it is labeled from 0 to 1, which means that we're dealing with less than a whole, which is a fraction, right? We're dealing with fractions. And so if you recall from our Number Corner video I posted on Friday, number one is that we have to see how the whole has been partitioned. And we do that by counting the number of jumps in between 0 and 1. So that's what the first thing I'm gonna do, is just gonna do some jumps to see how many jumps I have. So that's 1 jump, 2 jumps, 3 jumps, and 4 jumps. Okay, so my whole has been partitioned into 4. So I'm going to write that down as a statement. Make sure whatever I do, you're doing with me. I notice that the whole has been partitioned into fourths, which leads me to believe the denominator must be 4, right? Because there's 4 jumps, that means that the whole has been partitioned into fourths, and so each of the denominators for each of these tick marks will be 4. So I'm going to start by just setting that up, and then we'll talk about the numerator. So I'm going to just draw the line first, and remember 1 is also equivalent to another fraction, so that's why I'm leaving it like that. And then we know that let me get my pen out, not the lines. So I know that this is going to be 4 as my denominator, 4, 4, and 4. So, and I'm going to write the word or because 1 is also equivalent to another fraction, and we'll talk about that in a second. So now what am I going to do? Well, then I'm going to go back to the beginning of my number line and see how many pieces there are in this whole. And if I look, imagine this is just a really long piece of candy, right? Like an airhead. And this is the first piece that I cut. This should be then, the numerator should be 1. So this is 1/4. If this is 1/4, then this must be, say it with me, 2/4. This is 2/4, then this must be 3/4. And if this is 4/4, this must be 4/4. And if you recall, that's actually another claim that we'll talk about in another video, but 4/4 we know is equivalent to 1 whole because we know if the numerator and the denominator are the same, it's going to be equivalent to 1 whole. Bonus, I'm going to circle a fraction, and I want you to think, what is another way to say 2/4, or what's another fraction that is equivalent to 2/4? And it's a benchmark fraction that we always talk about. I'm like always saying this fraction, this benchmark fraction is like your best friend. And go. And if you said right now 2/4 is the same as 1/2, you are correct because 2 is half of 4 and 1 is half of 2. So give yourself some snaps, some little pats on your back if you're able to answer that correctly. So we're going to move on to the next thing on our slides to focus on our fraction claim. So I'm going to just clear these drawings, and we're going to go to the next page. So I'm actually going to ask you to write this claim down because this claim is really important in terms of us comparing fractions today. That is our learning intention, is that we're going to compare fractions that have the same numerator, so the same number on top but different denominators. So the numbers on the bottom are different from one another. So you're writing this down in your math notebook. Make sure you pause so that you have time to write it down. I'm going to read it and then you can pause. When the numerators are the same, look at the denominator. The smaller the denominator, the larger the piece. So pause me now so that you can jot that down. All right, and you're back. Well, what does that mean? We need a visual. So we're gonna add, not only did you write that definition down, or that, not definition, but that claim down, what we're going to do now is we're going to prove it with a bar model. We need to set up a bar model so that we can truly see it. Maybe, I don't know if I'll be able to do a pie model on here too, but we'll try it, so why not? So when the numerators are the same, look at the denominator. The smaller the denominator, the larger the piece. So I think I'm gonna do, let's write out these fractions. Let's do 1/2 and 1/4. So let's see if these two fractions fit this claim that we just wrote down. The numerators are the same. They are, because 1 is the numerator for 1/2 and then 1 is the numerator for 1/4. And then it says to look at the denominator. the smaller the denominator, the larger the piece. So I want to figure out which fraction is greater, if 1/2 is greater than 1/4, or if it's less, or if it's equivalent. Well, let's figure it out. Well, it seems, based on this claim, that the smaller the denominator, the larger the piece. Well, the denominator in 1/2 is a 2, which means that the piece would be larger, because 4 means that the piece would be smaller, right? Those pieces would end up being smaller. So right now, tentatively, which means right now, in this moment, I think I'm going to write that 1/2 is greater than 1/4, but that's not enough, right? We have to now prove it with the bar model, and then we're going to write a statement. So I'm going to check to see if I can do a model. And then let me grab another color so we can do side by side. And I'm trying my best to make sure that they're as equal as possible. It's kind of hard to do it on the computer, friends, but here we are, right? We're going to try our best. So for the first fraction, let's do the top one is going to represent 1/2. So I'm going to just cut it in half. Okay. And then I'm going to shade it in a second, so hold on. The bottom one, I know I have to partition into fourths. So I'm going to grab another color to do that. I have to partition that into fourths. So I'm going to just start by partitioning it down the middle like I did here. Maybe try to make that a little bit more straight so we can see that better. Trying my best, and then I'm going to partition it down this way. Okay, so then what I'm going to do is now I'm going to shade in. Let me grab another color. So the first fraction is 1/2, so I'm going to shade in. It's not a very bright color. Let's do green. I'm going to shade in 1/2 of it, right? That's one piece out of 1/2, or one piece out of this whole. And then the other one is 1/4. It's also one piece out of the 4 pieces. I tried my best to make it equal, but you can already see that it's still right. 1/2 is greater than 1/4. So what I'm gonna do now that I've used my claim and I've used a bar model, I'm going to type my statement, and I want you to write the statement. So we're gonna write, when comparing 1/2 to 1/4, 1/2 is greater because its denominator is a 2, which means the piece is smaller. The smaller the denominator, the larger the piece. And I'm going to just add another piece to that, or a little bit more. The bar model also demonstrates 1/2 is greater than 1/4. I want you to pause that right now so you guys can jot that down in your math notebook and just look at how juicy my statement is. I'm just going to read it one more time. I start with, when comparing 1/2 to 1/4. That's a good way to start that statement. When comparing to is greater, or is less than, or is equal to, because right? When comparing 1/2 to 1/4, 1/2 is greater because its denominator is a 2, which means the piece is, I meant to say bigger. The piece is bigger. Piece is larger. The smaller the denominator, the larger the piece. The bar model also demonstrates 1/2 is greater than 1/4, and I need a period at the end of that. So jot that now so you have some time to write it in your notebook so you guys can refer back to it. All right, friends. So I'm going to clear this now. Make sure you did write it down. And then we're going to continue with some practice. All right, so time to compare. And we need a recipe card. So I'm also going to ask you to write this recipe card down in your math notebook. Time to compare. So recipe card, look at the fractions being compared. That's number 1. Number 2, you're going to think to yourself, can I use a claim to compare the fractions? Number 3, support your answer by using a bar model or any other model. I do like the pie model. I'm just a little hesitant with it sometimes because some of you are not partitioning equally and doing equal parts, but you can try it. Just make sure that the parts are as equal as you can get them to be. And then number 4, write a statement explaining your thinking like I just showed you in the last one. So now it's your turn. I want you to write this recipe card down and you're gonna compare this fraction. You're gonna tell me whether 3/4 is, I'm gonna write the symbols, so you remember the symbols. If 3/4 is greater than, less than, or equal to 3/6. So pause the video so you can write the recipe card, write your comparison for 3/4 and 3/6. Make sure you make a bar model for it like it says in the recipe card, and make sure you use the claim in your statement. So maybe take 3 to 5 minutes to work on that. And if you see me talking again, it means that you've done the work, you wrote the recipe card down, you compared 3/4 and 3/6, and we're back. So I'm just gonna go through my recipe card just to make sure that I'm following step by step. Number 1, it says, look at the fractions being compared. So 3/4 and 3/6, so I have to figure out which one is greater than or less than, or if it's equal to. Now I'm gonna think to myself, can I use a claim to compare the fractions? Well, the claim that we talked about today and throughout the school year says, if the numerators are the same, look to the denominator. If I look, 3 is the numerator here, and 3 is the numerator here. They are the same. So now I have to look at the denominator. But the denominator here is a 4, and the denominator here is a 6. So my fraction claim says, when the numerators are the same, look at the denominator. The smaller the denominator, the larger the piece, which would tell me that 3/4 is greater than 3/6. So far I'm gonna write down that I think 3/4 is greater than 3/6. But now I have to support, if I look at step number 3 in my recipe card, I have to support my answer by using a bar model, okay? So I'm gonna do the same thing. Actually, let me try a pie model this time. It can be a bar model, pie model. Let me just see if I can make my model as equal as possible. Looks pretty good. And then maybe I can move it a little bit. It's not what I meant to do, but here we are. Okay, and then let's do some lines. So I know this one is partitioned into fourths. Use a different color. So one down the middle. And then this one like that. And then the other one is partitioned into 6. Remember the denominator tells us how the whole has been partitioned, which might be a little harder to do. I'm gonna try it, okay. It's kind of hard to do, but here we go. Let me try that again to try to make it a little bit more equal. It's kind of hard to do it, guys. I want to see if I can move this one. No. Okay. And then, so that's fourths, really big, unequal fourths. Okay. That's kind of hard, but let's try it. Let's just see, let's just compare to see. But this is what I mean with the pie model. Sometimes it's really, really hard to get the fractions or to partition it right. So you know what? I'm just gonna try it one more time. I think I just have to make these a little bit smaller. Maybe that's gonna be a little bit better this time. That's a little bit better than last time. Okay, here we go, right? Third time's a charm. So I'm gonna grab another color to shade in, and we're gonna see, we're gonna compare 3/4 and 3/6 to back up our claim that 3/4 is larger than 3/6. So 3 out of the 4 pieces need to be shaded. So that's 1, 2, 3. And then here, 3 out of the 6 need to be shaded. So 3 out of the 6 need to be shaded. Okay, so would I rather eat 3/4 of a pizza or 3/6 of a pizza? I'm looking at my fractions and I definitely would rather eat, if I'm really hungry, 3/4 of a pizza. I can clearly see that 3/4 is larger than 3/6. So what are we gonna do, friends? We are going to write a statement. When comparing 3/4 to 3/6, 3/4 is larger than 3/6. I know this because one fraction claim states if the numerators are the same, look at the denominators. The smaller the denominator, the larger the piece. Let me just make this way so you guys can see it more. This can also be proven with a pi model. Beautiful. Wow, what a juicy statement. When comparing 3/4 to 3/6, 3/4 is larger than 3/6. I know this because one fraction claim states if the numerators are the same, look at the denominators. The smaller the denominator, the larger the piece. This can also be proven with the pi model. Voila. Beautiful statement. So make sure you copy it down and you are ready because I'm about to clear all drawings. All right, my friends, we've come to the end of this video. You are going to write this exit ticket down, every word, yep, every word on it. I can already hear some of you say, but Ms. Maldonado, everything on this Google slide? Yes, everything on this Google slide. So it says, compare the following fractions in your notebook, write whether 1/5 is less than, greater than, or equivalent to 1/8. Make sure you explain why. Use a bar model and write your explanation using our fraction claim. Make sure you write this down exactly as you see it in your math notebook or a notebook, comparing 1/5 and 1/8, and send it to your teacher. Some of you are doing a fantastic job of sending me exit tickets. For my class in particular, like Scarlett, Kevin, Chloe, Diego, like I see you guys submit your work, but there are some of you who either forget to submit it or to send it to me. This has to be a picture that your parents send me or send to Ms. Alonso or Ms. Delgado. My friends, it's really hard to keep track of who needs what, so it's really, really important that you send us a picture of the exit ticket so we know whether you need extra help or not on this. We're trying to get you as ready as possible for 4th grade. So, see you guys in the next video, and I hope you have a beautiful, beautiful day.